Good morning, Trig. We are going to cover another review section from Algebra 2, Percentiles and Z-Scores. So this looks at statistical data, so like the average height, the average test score, the average SAT score. It looks at averages, and when we convert things to percentages, then we can compare them. So for example, like right now, the really only comparable data is percentage of cases per population because some states have more people than others. Anyways, so let's jump into lesson 70. You are going to need your book because it has the Z-score table in the back. So let's go over some symbols. This theta x symbol represents standard deviation. They also might just use the theta symbol without x, but that refers to standard deviation. That's the average distance your data is from the mean. X with the bar over this, this is the symbol for mean. Well, the old symbol for mean. In this section, it goes over a new Greek symbol, or the Greek letter mu, or mu. It's kind of weird. But this also represents your mean, right? Another word for average. And I've also recorded your formula for Z-score, and we're going to use that today. So it is your data minus the mean divided by your standard deviation. Okay, so this is your data value. This is your mean. And that is your standard deviation. So we're going to do a couple of examples. Again, like I mentioned, in your trig book on page, hopefully I wrote the right page number, 442, and I'm going to have that open because I have a feeling we're going to need it. You will need, it has the a small version of your Z-score table. I don't know if there is a full version in the back, but maybe that's because we don't need it. I don't see a full version in the back, but there is a short version of it, okay? So I'm going to do a couple examples with you. So number one, suppose that 2 million seniors take the exact same test. The mean is 150. So that's the mean score, and your standard deviation is 10. So let's first talk about what this would look like on a standard bell curve. We also call this a normal distribution. Okay, so our mean would go down the center. So our mean is 150, right? That's what they told us. And I would divide the top half into 3 bars, and each bar is plus 1 standard deviation. Our standard deviation was 10, so this would be 160, 170, 180. To the left, I should be subtracting, so this would be a score of 140, 130, 120. And this is getting into some statistics, but if you remember, from the middle, each one to the left is, this is 34% of your data, and this is 34%. So this first standard deviation to the left and to the right is 68%. So that would say that 68% of students scored between a 140 and a 160. As you work your way out, they get smaller, so 13.5%, 13.5%. This is in the book. So, but from here to here, I believe, is 95. That should be right. 68. If I'm wrong, I'm gonna hurt myself. 68 plus 27. Yeah, this is 95%. So 95% of students scored between a 130 and a 170. And then each of these only represents 2% of our data. So 99 or almost 100% of our students of seniors score between a 120 and a 180. So that is what that is saying. So let's talk about some students. So Charlie scored 150. Well, that means that he scored just going over how to read this. He scored higher than 50% of seniors. So we would say he's in the 50th percentile. Okay. And I know that because if he scored a 150, 34 plus 13.5 plus 2 is 49.5. Do you see it? And so he scored in the 50th percentile because 50% of the students are underneath him. So that is using like the normal distribution table. Zeke scored 175. 175 is not listed on here, so this is where we would do the Z-score. So I would say, okay, he scored a 175. I'm going to subtract my mean, which is 150. I'm going to divide by my standard deviation. So 175 minus 150 is 25 divided by 10 gives me 2.5. So this is my Z-score. If you go to page 442 and you look for a positive 2, so go down to positive 2, and then over 0.5, there's this little data point right here, 0.9938. So I'm going to write 0.9938. That means that he is in the 99th percentile, which means he scored higher than 99% of all seniors. Now, I don't know if you've taken the PSAT, but they give you this data on your feedback. They give you the printout and what percentile you're in. And that tells you how well you did compared to everybody else that took it. Okay, so we are going to move on to another type of problem using this data. So the average weight of babies was 6.8 pounds. Standard deviation, that's what the symbol is, 0.8 pounds. What percentage of babies weighed less than 6.4? All right, so I'm going to do my Z-score. It is, remember, I gave you the formula. It's our data minus the mean divided by the standard deviation. So our data is 6.4 minus the mean divided by the standard deviation. And so I get, if I enter that, 6.4 minus 6.8 divided by 0.8, I got negative 0.5. So remember, this first number is on the left, and this is the top number on page 442. So I'm looking at negative 0. So that would be here. And I'm going to go over 0.5, so I get 0.3085. So the percent of babies that weighed less than 6.4 is 30.85%. Now, true story, my first daughter weighed 8 pounds 7 ounces, quite a bit above the average. So what percentile was she in? What was the percentile the hospital told me? Well, first I have to convert this to pounds. So she was 8 pounds 7 ounces. There are 16 ounces in 1 pound. So I'm converting this so that it is all in pounds. So I need to know, is this 8 point what of a pound? So 7 divided by 16, she was 8.4375 pounds. So now I can calculate Z-score. So my Z-score equals my daughter's weight minus the average divided by the standard deviation. If I enter that in my calculator, I got 2.05. So I'm gonna round that to 2.1. And so 2 is the number on the left, 0.1, 0.9821. Wait, do I have? well, actually, I mean, she would be exactly in the middle, right, of 2.0 and 2.1. She would be in between these two data points. So I'm going to record them both. She is right in the middle. 2.05 is in the middle of 2.0 and 2.1. And so for 2.0, I get 0.9772. And 2.1, I get 0.9821. So if I average those out, 0.9772 plus 0.9821 divided by 2, I get 0.979. So she was in the 98th percentile. Meaning she weighed more than 98% of babies born that year. She was a big baby. All right, last one. What percentage of babies were born weighing between 6 and 7 pounds? So I'm going to calculate each. I'm going to calculate the z-score of 6 pounds and the z-score of 7 pounds. So 6 minus 6.8 divided by 0.8. And this one would be 7 minus 6.8 divided by 0.8. So I'm going to calculate the z-score of each to find the percentage of babies born in between. So for 6 pounds, I got negative 1.0. And for 7 pounds, I got 0.25. So I'm going to look up each of those. So for negative 1.0, I got 0.1587. It's right here. Sorry. And then for the 0.25, it would be 0. It'd be in between, right? Here's 0. 0.25 would be right in between 0.5793 and 0.6179. So for this one, I have to, again, find the average. So 0.5793 plus 0.6179 divided by 2, 0.5986. So I'm going to subtract the 2. 0.5986 minus 0.1587. And that should give me close to 44%. I'm rounding, but to get an exact, I get 0.4399, so 44% of babies are born between 6 and 7 pounds. So again, this is review. Use these notes if you need them. For homework 70, we're going to skip numbers 3, 4, 15, 22, 26, and 30. Thank you.